Okay, so this is part three and the final part, a video series for a lecture on human land use decisions and natural resources ecology at SUNY ESF. So you should have just watched a video produced by the Southern Property staff at Heiberg Forest here at ESF about how trees are tapped and utilized to make maple sugar, maple syrup at Heiberg. And you are, as part of a lab exercise, you are going to see a sugar bush, and we'll talk about sugar bush management. So let's talk a bit more about the basics of tapping trees for production of sugar. Many of you in this class will have had direct experience doing this, perhaps on a small scale, and some of you, if previous years are any indication, might have experience doing this with hundreds or even thousands of taps in relatively large operations. So many species of tree can be tapped to acquire the liquid sap in their stem. Uh, and that includes particularly the maples, but many other species. Birch and walnut and sycamore are among them. And so that the water inside the stem of a tree, particularly in this spring transitional period, contains enough sugar to be valuable and useful to humans. But approximately 40 gallons of sap need to be boiled down to and concentrated to produce 1 gallon of syrup. And so an Acer saccharum, or sugar maple, given its name, it does contain the highest concentration of sugar in sap, and thus other species that are tapped, like black walnut, which produces amazingly tasty syrup, they have a larger ratio here, right, because the original sugar concentration is lower. But there, and this syrup can also be made into other products that increase value. So historically, there was a large production of maple syrup in the 1880s here for the United States and here for Canada. And as there was this move away from families from the forest and the concentration of people in cities, the production of maple syrup actually has declined historically in the United States, but is making a resurgence and is very big business in Canada, particularly southeastern Canada. We recognize that Native Americans also harvested the sap of sugar maples and used it themselves. Um, and so let's talk about some of the history of this. So Native Americans used buckets and used gashes to open up and expose a wound that weeped sap into these birch bark buckets that were then boiled in log boilers. European settlers brought metal tools and practices that in this consumption of maple syrup actually peaked during the Civil War. And so here is a depiction of how it used to be done. You notice the hand drill of this man drilling a hole into the stem of a tree. Notice the horse-drawn carriage in the back of how the sap was transported, and this bucket that was placed on the tree to collect the sap of an individual tap hole. And the current production methods are quite different, although small-scale collectors will still use this bucket method, which works well on a small number of trees. So a hobbyist that has a few trees in his backyard can still collect sap and boil it on his or her stove in the maybe out in the back shed or even in the kitchen and produce a small amount of syrup for themselves. But now the methodology has changed substantially, and a large number of trees are generally connected by vacuum tubing, and more infrastructure is used to collect a larger volume of sap from many trees, and to scale this up to industrial scales. So what's actually happening? So the physiology by which maples and other trees produce useful sap is actually one of these things that we're still getting a handle on. Well, you'd think we'd know this by now, and it's so in general what's absolutely agreed upon is the environmental conditions that drive sap flow. What's not agreed upon is the exact physiological mechanism underneath and explaining that flow. But sap flows when we have a strong difference in the day and nighttime temperature that span the freezing mark. So for sap to flow, we need very strongly cold and freezing nights that are followed by very warm days that are warmer than freezing. This often occurs in the spring. And so the thought is that those freezing temperatures at night causes the water inside of the tree stem to freeze, and the solubility of lots of gases in that water to increase. Solubility of gases increases in cold water, and so lots of dissolved CO2 would exist in the water inside the tree stem. That dissolved CO2, think of it just like a highly concentrated and carbonated soda that has a lot of dissolved CO2 in it. And that during the day, when the conditions get much warmer, the water thaws, that CO2 becomes less soluble, and you get the expansion of gas of that CO2 pops out of solution, and we have these literal gas bubbles that increase the pressure in the stem that pushes the syrup out the spout of the tree here. There's actually some controversy about whether it's really coming up from the roots or coming down from the canopy, and I actually think the tree physiological community is thinking this sap actually is coming down from the crown of the tree and driving sap out of this hole rather than coming up from root pressure. But in any case, we can drill a tap into a tree, and if we do this thoughtfully, we can do it without strongly harming the tree. We attach vacuum tubing, and there's been some development in creating taps and tubings that produce smaller wounds than previous methods. On trees, that tap then needs to be removed at the end of the tapping season in the late spring, and that tree will heal over time. And then the next winter, the maple sugar will drill a new hole, install a new tap in a slightly different part of the tree stem. And so over time, each year, we need to drill a new hole, install a new tap. And for a healthy, rapidly growing tree, by the time we get around that tree and back to the same place, the hope is that tree will have substantially increased in size and have grown over, produce new wood. That tree is now larger, that will be able to tap a similar location again. But there's an economic issue here in that most of the wood value a tree has is of that lower log where the tree is the widest. And so we're continuously tapping and damaging the wood that would be most valuable for saw log values. And so there's a potential loss of wood value in tapping of trees, but there's also a specialty market for tap hole maple that might actually bring it to a premium wood product. So this is an example of tap hole maple, of a wood product made out of maple that includes the imperfections of tapping holes and the resulting growth. And so when this wood is specifically used and marketed in this way, it can make valuable wood products. So when we take the class and we go into the sugar bush, you'll be in a forest that has trees and tubing going through it, but I'll encourage you also to notice other aspects of that forested stand, to look for evidence of previous human land use decisions. What species of trees are there? What is present in the understory? What is the structure of the above ground canopy? And we'll think about the land use decisions that an owner might make to create a functional and viable sugar bush environment. So many of the things that I would expect you to notice walking through the sugar bush is a large portion of tappable trees, mostly maples, right? So the sugar bush was established in this stand because there were a lot of maples there. There were some decisions made about removing some of the trees that weren't desirable. You will see a lack of species that make large large nuts, in particular oaks. Species that make those kinds of nuts attract things like squirrels, which also will chew on the lines and cause damage. There's also will be a remarkable lack of other evergreen species. So remember that the sap needs to flow in the spring under a nice warm day that follows a very cold night, and that we need a lot of solar energy to get down to the stems of these trees and the lines to heat them up and allow the sap to flow at a temperature that's higher than 0 degrees Celsius. And so evergreens that would shade this environment would not be desirable. So you should see a forest that composed mainly of tappable trees because the other ones had been removed. And of course, the sugar bush was intentionally, people made a decision to place it here because there were a lot of maples. And then there were also the intentional decisions of leaving behind healthy maple trees with very large spreading crowns that compose a lot of the overstory. Ideally, the site would also have accessible. People would need to move through it and work in it relatively frequently, and things like shrubs and briars and beech thickets would be a problem. Although if we open up the canopy too much to benefit our maples, we might also change the understory in ways that aren't desirable. Sugar bushes are often established on land that is gently sloping, such that gravity can be used in designing the flow of the tubing to use gravity to help distribute the sap when possible. So I encourage you to think about and notice these things as we go through the sugar bush. There's often the opportunity to use a sugar bush for side benefits, for firewood, and some of those trees that are removed when establishing the sugar bush can be used to provide firewood, and that firewood could be used for boiling the sap. And there's lots of other potential ways that perhaps are not used widely, but are other potential ways to add value and add income to a sugar bush operator as well. And so we're going to go to this sugar bush at Heiberg Forest, and now you know that these are vacuum lines that connect a bunch of trees in this sloped landscape, connecting down to a centralized location. There are taps in trees. Individual trees are connected to these distribution lines. The top one is held under vacuum, and that helps to pull the sap out of the trees, and this bottom one will fill up with sap and moving water back down to a collection house here. And so the topography is set up that there's this hill that slopes down to a collection line that goes to the collection location. And the slope goes down from the hill downwards, from the hill downwards, from the hill downward down into this centralized collection facility at Heiberg. And so that's the end of this lecture series. We've talked about human land use decisions and how human decisions shaped by economic and regional forces influence the structure and function of forests that we see in the Northeast. And this has also been a prelude to a lab where we will go to a sugar bush at Heiberg Forest and see examples of this in action. Thanks very much.